Welcome to Electrical Fundamentals, Understanding AWG Wire Gauge. This practical guide covers wire sizing for industrial controls, machinery, and manufacturing environments. Stay tuned for a 2 to 3 minute watch. What is AWG? AWG stands for American Wire Gauge, the U.S. standard for measuring electrical conductor diameter. A higher number means a thinner wire, such as 30 gauge for fine instrumentation wire. A lower number, like 2/0 gauge, feeds heavy motor loads. Thicker conductors handle higher amperage safely, while undersized wire risks overheating, tripping protection, or causing fires. The AWG scale works backwards. The higher the number, the smaller and thinner the conductor. For example, 2/0 gauge handles 175 amps for motor feeders. 8 gauge supports 50 amps for CNC machine feeds. 14 gauge carries 15 amps for control panel wires. 20 gauge is used for PLC I/O wiring with 5 amps. And 24 gauge is suitable for sensor or signal applications at 0.5 amps. Remember, larger wire means more current and a lower gauge number. Common AWG sizes in industrial use are summarized here. 2/0 gauge handles up to 175 amps for large motor feeders and busbars and 50 to 100 horsepower motor circuits. 4 gauge supports 95 amps for motor branch circuits and welders, ideal for 25 to 50 horsepower drives. 8 gauge is used for CNC machines and robotics power feeds at 50 amps. 14 gauge manages 15 amps for control panel wiring. 18 gauge is typical for PLC I/O wiring and relay coils at 7 amps. Sensor leads and analog signal wiring often use 22 to 24 gauge for 2 amps. Ampacity values are for copper conductors and conduit at 75 degrees Celsius per NEC 310.15, and panel wiring is governed by NFPA 79. How do you pick the right gauge? First, determine the load current by checking the motor nameplate or device spec sheet. Size to 125% of full load amps for motors per NEC 430. Second, account for run length. Long cable runs increase voltage drop, so upsize conductors for runs over 100 feet to stay within 3%. Third, apply the right standard. Power cables follow NEC 310.5 control panel wiring uses NFPA 79, and VFD cables require shielded conductors. The golden rule: when in doubt, go one size up. A slightly larger conductor costs little extra, but an undersized wire can cause downtime and hazards. In industrial and manufacturing applications, motor branch circuits use 8 to 12 gauge, sized at 125% of motor full load amps and compliant with NEC 430. VFD to motor cables use 12 to 6 gauge with shielded, low capacitance, symmetrical 3-ground design. Control panel wiring uses 14 to 18 gauge, following NFPA 79 or IEC 60204. With 600-volt MTW or THHN insulation. PLC I/O signal wire uses 20 to 22 gauge shielded twisted pair for 24-volt DC discrete and analog signals. Thermocouple extension requires 20 to 24 gauge, matching the thermocouple type with low noise shielded pairs. Instrumentation loop uses 18 to 22 gauge for 4 to 20 milliamp process signals, with shields grounded at one end. Here are the key takeaways. A higher gauge number means thinner wire and lower current capacity. Size motor branch circuits at 125% of full load amps per NEC Article 430. Long plant floor runs require upsized conductors to stay within 3% voltage drop. VFD cables must be shielded, as standard THHN and conduit can cause EMI problems. Control panel wiring follows NFPA 79, so always verify insulation type and temperature rating. For compliant designs, consult your machine builder specs, NEC Article 4.3 and NFPA 79.